Tom here, and thank you for coming. I am so excited that you're here because we're going to learn about performance tuning of big data systems. I've been doing this for 25 years, and I thought I knew what I was doing until I saw this segment, and it changed my whole career, really my whole life when it came to seeing the data and understanding, frankly, what's really going on. And I'm going to explain that to you today. When I'm done, you're going to go, you know what? I see data. I see it in the blocks. I see how it moves into memory. I see how these systems process it and all the options I have when I'm creating these tables. And the SQL I'm writing, I know it can't be better. And we're going to start with you thinking about this. Data blocks are just like you going to the airport. And you know, I remember the last time I went to the airport.
Welcome, sir, to your favorite airline.
Whew! That was tough, but I'm really strong. Sorry, ladies. I'm already taken.
And I was hoping to find my trophy husband today. May I see your ticket? And could you put the bag on the scale?
Here's the ticket, and the bag is... It's up.
Ooh, this is going to be a problem.
A problem? I'm a paying customer. I demand good service.
It weighs 300 pounds, sir. No one can lift it.
Too heavy! I had Grandma lift it in the car for me.
And how is Grandma Schwarzenegger? And secondly, sir, it won't fit through the cargo door.
I think I've taken this bag before on another plane.
Perhaps the space shuttle? Hey Karen, John Glenn's with us today.
Aha! What about if I split the bag into 2 suitcases?
More like 6 suitcases, sir. But good news, your loan's been approved.
Oh!
Next in line?
Let's talk about big data. And before we even get to those data blocks, let's understand parallel processing. Take a look right here. You just went into the laundromat and it was completely empty. So you took all of your clothes and you put them in the washing machines and you synchronized them to put those quarters in at the same time and started it. And when it was done, you did the same thing with the dryers. You were the boss. You told those washing and drying machines what to do and when to do it. You have never felt so much power, and you got this stuff done in about an hour. That's the way parallel processing works on computers, except this is the way you need to think about big systems, big data. They're called MPP systems. That stands for massively parallel processing. But don't think of them that way. Think of them, instead of these washing and drying machines, like 8 personal computers all connected to a network with a boss shouting out the orders. Take a look here. You can see that I have got 8 PCs. Each one of those represent their own parallel process. You see, those will be called amps on Teradata. They'll be called spoos on Netezza. They will be called segments on Vertica and Greenplum. They're going to be called slices on Amazon Redshift. And they're going to be called distributions on Azure SQL Data Warehouse. But it doesn't matter. All of these big MPP systems really need to be thought about like they are a bunch of separate PCs, because each one of these parallel processes is just like a PC. It has its own CPU. It has its own memory. It has its own disk. It has its own operating system. This is a shared nothing environment. Just like your PC and your spouse's PC, these are separate systems. But the real key here, they're connected to a network. They have got a boss that's telling them exactly what to do simultaneously. And that's how big data works. We're going to create our first table on a big data system, and we put in the create statement, and guess what? That goes to every single one of those PCs amps, segments, slices, distributions. And they all say, you know what? I just got myself a table. I own this table. And the person next to him says, yeah, I own it too. I own it 3. As a matter of fact, if you had 1,000 of these PCs, they would all have the exact same table structure. And then when you began to load data, they would all get separate rows. Just like you put your wash into separate washing machines. You put the rows and distribute those among those PCs until when it's all done, they all have an equal amount of the rows that they're responsible for. That's the way big data works. So the boss says, everybody, I'm creating this table. You should be getting it. Let me know. And they got it. Then it says, I'm going to load this data. And here's what they're going to do. They're going to each say, okay, we're loading the data. The boss says, get it ready. They are going to open a small block. And when this block fills up, they go, oh, you know what? This table looks like it's going to get a little bigger. As this gets bigger, they continue to expand that block as needed. And each one of these are simultaneously doing this because they're all getting their rows about the same time. When this block reaches 1 megabyte in size, they're going to split it. And half the data is going to go into this block. Half the data is going to go into this block. And it's going to be sorted. I want you to imagine this is almost like a phone book. Okay, this is A to L data, M to Z data. It's going to continue to grow and split and split. You might have 1,000 personal computers, each with 1,000 blocks for this table. That's 1,000,000 blocks of data in this table. That's big data. Performance tuning. Listen to me very carefully. Get a little closer. Come on. Performance tuning is about not reading every block of a table. The fastest performance tuning is going to be if you use the distribution key. The fastest performance tuning was to call one of those PCs and it moved 1 block into memory. That is the ultimate of performance tuning. You're also going to see some queries where they actually say, oh, I have a unique secondary index, and the system created another little baby table that was designed to point to the bigger table. So they had 1 block read on 1 PC that was from the little secondary index subtable, which called 1 block on the base table. And they go, oh my goodness, out of 1,000 of those PCs, only 2 were called and only 2 blocks were read. That's the second fastest query. Then they're going to talk about partitioning of data. You're going to hear that and you're going to go, I am nervous. Partitioning, here's the way it's going to work. Each one of these personal computers is going to get many blocks, but it's going to say, you know what? When you partition a table, all you're really doing is telling that PC, and all of them simultaneously, sort this data by order date. And they go, well, listen, that means all of the January orders are going to be in this block. And the February orders are going to be in this block. Oh, and the March orders are going to be down in this block. And it's going to go all the way down to December. So when you run a query and you go, you know what? Select all orders that happened the first week of January. All 1,000 of these PCs are going to work together. They're going to be involved, but they're going to go, oh, I don't have to read 1,000 blocks. I just have to read the ones at the top that represent the January data. And once again, the performance tuning on this said, don't read every block. Finally, somebody came up with Columnar. It is the most brilliant idea. I think it's the future of computing. So the boss says, everybody, I'm creating this table. You should be getting it. Then it says, I'm going to load this data. They got it. So they'll all get their portion of the rows. But when they get those rows, they'll say, this is a columnar table. I want you to store, of the rows you own, PC, I want you to store the order numbers in a block. In a separate block, but same order, put the customer numbers. Put the order dates and the order totals. This isn't one big block. This is 4 separate blocks. The tricky part is they got to keep that data synchronized. So if they actually delete a row, they go, oh, no. Just mark it as deleted because we don't want to mess up any balance here. But if they keep everything in perfect order, when you run a query now and say, give me the average order total, they didn't have, like in a row system, to move all of the entire row in and say, well, we just need this little piece here to do the aggregation of the order totals. They actually go, wait a second, this is another way we don't have to move all of the data in because, did you say give me the average order total? Hey, PCs, just move your thin block of the order totals into memory, and once again, it's going to be so much faster. I hope you've enjoyed today's presentation because guess what? Performance tuning is all about not reading all of the data from disk into memory. It's all about minimizing the block movement from disk to memory.